So on this video, we're going to talk about what I think is the quickest way to find the vertex of a parabola when it's written like this, where it's not in the so-called graphing form. We've talked about graph shifting. If you had a base graph of x squared and your function looked like this, we could view this as a parabola that has been shifted, remember, right 3 units, and the +1 moves it up 1. So we could then figure out that the vertex of this parabola would no longer be at 0, 0. It would be over to the right up 1. So the vertex would be at 3, 1. So if your parabola is written in that form, then yes, that would be very easy to go ahead and find the vertex that way. But a lot of times your parabolas are written like this, where it's all multiplied out. And so there is a nice quick method to find the vertex of this. The way I'm actually going to start this, which is going to lead into my method, is I'm going to find the x-intercepts of this parabola. And remember, to find my x-intercepts, I'm always setting y equal to 0. If I set this function equal to 0 and factor it, it factors into x minus 8 times x plus 2. So my 2 x-intercepts, if I set each of these equal to 0, I get x-intercepts of 8 and -2. So these would be what I'm doing here is finding my x-intercepts. Now, just knowing those x-intercepts, I'm just going to roughly draw it. So here's -2, +8, maybe like right over here. If we know those are the x-intercepts, we also know our parabola opens upwards. And we know that parabolas are symmetrical. So if you think about where would the bottom of it be, where would the vertex be, it should be right in between my 2 x-intercepts, right? That should be the x-coordinate of my vertex should be right in between here. So how do I find a number right in between two numbers? I add them together. And so I'm going to average my numbers here. And let's call this, because we're only finding the x value of our vertex, so I'm going to introduce this notation. V for vertex, V sub x, what I would do is add these two numbers together and then divide by 2. That's how you find a number halfway between two things. So that's going to give me 6/2, which gives me 3. And you notice that's 5 units from 8, and 3 is 5 units from -2. So I know the x-coordinate of my vertex is 3. What about my y-coordinate? How would I find my y-coordinate, which I'll denote as v sub y? Well, I would just plug 3 back into my equation. So that is just going to be f of 3. Now you can plug it into here. You can also plug it in here. Remember that this is the same equation as that. It's just in factored form. And oftentimes it's easier to plug in to the factored form, which is what I'm going to do. 3 minus 8 is -5. 3 plus 2 is +5. -5 times +5 is -25, okay? So my vertex is 3, -25. I'm obviously not going to be able to draw that to scale, but my parabola would look something like this. And this bottom of my vertex, I would then know is at 3, -25. That's the minimum value, the lowest point on my parabola. Okay, so this is another technique, right? If you've got a parabola, you could find the x-intercepts and know that your x-coordinate of your vertex is going to be right in between your 2 x-intercepts. You would average your x-intercepts, add them together, divide by 2 to get your x-coordinate, and then you could plug that into your function to find your y value. Okay, now do you see any drawbacks with this method? Right? Will this method always work? Well, what about, okay, I was thinking on this one we just did right here, I didn't draw any axes in, but if I did draw some axes in, this would be x, this would be y, right? Because it's over 3 up 1. Why wouldn't this method appear not to work if my parabola was this? How many x-intercepts does this parabola have? It doesn't have any, right? If the vertex is at 3, 1 and it's opening upward, it's never going to cross the x-axis. So it would seem like this method of finding the x-intercepts and finding the average of the x-intercepts would not work if you had a parabola that didn't have any x-intercepts, right? What's the other bit of messiness? Well, what if this factored nicely, right? But I'm sure you've encountered some quadratic equations that don't factor nicely. How would I use this method if my intercepts don't come out nicely? Well, what I want to show you is that this method still works no matter what parabola you have. So let me show you that. So let's say I try this same technique of finding the midpoint of the x-intercept to find v sub x for f of x equals ax squared plus bx plus c. Now, what am I really showing you? What is this? This is not just another parabola. This is every parabola, isn't it? Every parabola you could ever come up with would have a form like that, ax squared plus bx plus c. Okay, including ones that don't have any x-intercepts. And that might seem surprising, like how am I going to do this if there's no x-intercepts? But let's just try this. So if I was going to do this method, I would first find my x-intercepts by setting y equal to 0. Okay, now in the previous one, I factored it, but I can't factor that. So what's my backup if this doesn't factor is to use the quadratic formula. So my two x-intercepts would be, one of it would be negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, right? That's our quadratic formula. Now do you see there's actually two x-intercepts there, huh? One of them is negative b plus the square root over 2a, the other one's negative b minus. And if I'm going to find the midpoint, what do I do with my two x-intercepts? I need to add them together and then divide by 2. Go back to this example here. Once I had my x-intercepts, I added them together, divide by 2, and that told me the x-coordinate of my vertex. So let's try it here. I know this seems weird, but let's try it. My first x-intercept is negative b plus the square root of b squared minus 4ac over 2a. And then I want to add my other x-intercept, which is negative b minus the square root of b squared minus 4ac all over 2a. And then I want to add them together and then divide by 2. Well, look in the numerator. These have the same denominators, so I could combine this to a single fraction, and what would I have? I would have negative b plus the square root plus negative b minus the square root. I'm not even going to write what's inside there because what's going to happen? And they would have the same denominator over 2a. Do you see that they're going to cancel, right? That's a positive square root, that's a minus square root. And then the other thing is, instead of dividing by 2, I'm going to say that's the same as multiplying by 1/2. So this 2, I'm writing as times 1/2. Negative b plus negative b gives me negative 2b divided by 2a. And if I times that by 1/2, I get those two to cancel. And what I find is v sub x, the x coordinate of my vertex, is always going to be, this is the shortcut I was referring to, or the quick way. It's always going to be negative b over 2a will give me the x coordinate of my vertex. Okay, and so this is a really good thing to know in pre-calc, especially because you're going to be doing a lot of stuff with parabolas, and knowing how to find the vertex in the most efficient way is going to be in your interest. So let's try that for a couple of parabolas, negative b over 2a. So here's one. I want to find the vertex of it. I don't need to do the x-intercepts anymore. That was just to lead to that formula. So I know my x-coordinate of my vertex is negative b over 2a. My b is negative 8, so it's the negative of negative 8. And my a is 2 over 2 times 2. That gives me 8 over 4, which is 2. So I know the x-coordinate of my vertex is 2. To find my y value, I'm just going to plug 2 right back into my equation. Here I do have to just plug it in. So that's 2 times 2 squared. 2 squared is 4, times 2 is 8. So we have 8. That's going to be minus 16. 8 minus 16 is -8. -8 plus 7 looks like I'm getting -1 for my y value. So this parabola, I'll just draw like a little fake parabola here, would have a vertex at 2, -1. One more. Might be good for you to pause the video and try this one. So v sub x is -b over 2a. So I'm going to get the negative of -6 over 2 times my a here. I have to take the negative, would be -1. So that gives me +6 over -2, which gives me -3. And then plug that in to find my y value. So it's going to be negative. Okay, this one I think I should write out because too many negatives. I'm putting -3 in for x, so -6 times -3 plus 2. This is +9 when I square -3, but then I apply the negative, I get -9 plus 18 plus 2. That's going to give me +9 plus 2 gives me 11. So this one's an upside down parabola, so I know it would go like this, and the vertex, that maximum value here would be at -3, 11. Okay, so if you can remember -b over 2a, I think you're going to find it much faster for finding the vertex of a parabola. No more completing the square. You don't have to do the midpoint of the x-intercepts. You can just go straight to -b over 2a, and it will give you the vertex really fast.